Alright, that's the electrolytics finished. Here are those two that have the positive going to the chassis, mounted down in there, firmly attached to that guy. Now there is another reason to use these, is that they're all mounted underneath the chassis, which gets mounted firmly to the bottom of the cabinet. There's no air circulation. So things can get toasty down here, especially when you got a big old power resistor like this. Well, it's pretty far away. So when there's limited ventilation, there's going to be heat buildup. The number one enemy to electrolytic caps is heat. These axial guys are big, and they've got long leads, so that will help spread out the heat versus using tiny, skinny, radial leaded caps. Alright, now let's see about undoing this guy. I'll tell you, this is a really peculiar set to work on. Well, I should say the odors it emits are peculiar when I heat it up. Especially where it looks like somebody has worked before, like these two wires. Clearly somebody reworked these. It kind of smells like several packs worth of cigarettes, to be honest. I don't know if when they were soldering in a really smoke-filled workspace, could that have absorbed it? Or is it just the way the rosin that they use smelled? I don't know. But it's not entirely pleasant, I gotta say. So these two wires go up through a hole to that box. I think these are the filament supply. I could be wrong about that. They don't appear to have... They're not color-coded or anything, so I don't think it matters which goes where. I say, optimistically, as I'm about to disconnect them. I'm going to throw a little fresh solder on these joints too. Now, if it's like the other reworked joints I've encountered, these wires are not even going to be looped around. They're just going to be pressed against. Most of these that I've heated up, the leads just fell away. In other words, I just put the stripped end of the wire against the joint and soldered it on the side. They didn't put it through the eyelet. They didn't wrap it around. That one I wrapped around a little bit, but some of these others, it was just really atrociously bad soldering. It makes it easier for me to get it apart, but not the best job. That didn't smell quite so horrible as some of these other joints. We have two more to disconnect. Those are up here next to this peculiar looking transformer thingy. Filter choke probably. You can see they melted the insulation on this wire when they worked on it. So it says it was clear somebody had disconnected these wires, I'm sure, because they took that box apart at some point. I'm really curious to see what did they do. Not easy to get up those wires. Try doing this bottom one. Something else about this set. So it seemed at first like it was really high quality, Hallicrafters, known for making communication receivers. But in a lot of places it's actually not. Not the best terminal strips that they use, and they used very few. Most of it's done going from tube socket lug to tube socket lug. The wiring they used seems like a decade old, pushback cloth covered wiring. By the late 40s, most manufacturers were using plastic like they use on this high voltage control next to me. Yeah, okay, that connection was just press fit against, and I can see there's a lot of old wire. They didn't clean the old wire off the lug, they just cut it and then didn't reattach it very securely. So yeah, overall the construction quality, I was surprised. I looked up the price on this set, and this sold for, I believe it was $169 or $139, something like that, versus $199 for a comparable Motorola set at the same time. I think the Motorola was $199, the Admiral was $169, this was $139, something like that. So yeah, they cut costs. I think not having a shield on the CRT, rather crude construction. I would have thought it would cost more to make this at first because it's elaborate push button tuning. I don't know. Just my observations from working on it, it's not the greatest quality. But I've definitely seen worse as well. So how do we mount that box? Let's see, maybe it's attached on the top. Yeah, okay, it's attached on the top side. There are right angle brackets and 1/4-inch sheet metal screws we have to remove. So I have 4 of those. Then this will come out, and there are components on the other side of that board. It's one. It's entirely possible they sold this set at a loss. In spite of some wiring issues and whatnot, there's a lot of fixed costs. CRT being one of the more expensive things. The cabinet seems like it'd be pretty expensive compared to just the wooden boxes used in some others. It's a large chassis. It's a high tube count. There's a bunch of 12SN7s in this thing. Alright, so it's loose. So it can be hung up. Let's check the wires underneath. I missed one wire. There's a ground wire. Going here. Yep. Again, not secured very well. Just a little bit of heat and it came right off. The reason this fell over is I was propping it up against that high voltage box, which has now been unmounted. Oh, come on. What is the problem? It's the matter of these wires being kind of stiff and crusty. Hold up on things. Alright. Tools are falling everywhere. Holla. Oh, I'm glad I opened this up. Big old fat caps down there. These are replacements though, but they're ancient replacements. Like the replacements look as old as the science. There's a mica mold, 0.25 megafarad 600 volt caps, and a 0.001 megafarad 4000. That is not what it should be. That should be a 6,000 volt cap. That could not have done this set any good. The schematic calls for dual 500s in parallel. Likewise over here, I replaced that with a single 1000 picofarad. And similarly here, it looks like they probably replaced what was originally a couple 500 picofarads with 1000 picofarad. There's no reason not to. They were probably just cost conscious and they used 2 originally. But 4000 is not going to cut it. This is the highest potential point in the set. And it's going to have, assuming this thing's working properly and you want a nice bright image, there should be over 4,000 volts there. The max on a 7JP4 I believe is 6,000. Typical operation is between 5 and 6, 5,500 thereabouts. the higher you get, the brighter the image is going to be. You don't want to exceed it really, though, or you're liable to start burning out the phosphor or get arcing. That is a weird looking cap too. Let's clip that guy out. I think that might be an oil filled something. Well, let's take a picture for posterity first. So clearly the set had been tinkered on and worked on, but I'm thinking it was worked on not a whole lot long after it was made. Of course, by the end of the 50s, and these sets were laughably obsolete. Of course, if you didn't have any TV, it's better than nothing. That thing is weird, crusty. So this is a plastic insulating, it's almost like heat shrink tubing over a metal cap. There's a big, thick phenolic plug on the end with a lead coming out. It's probably some kind of oil-filled paper cap. Does not look very good. Very sound. What I find a little bit odd is a capacitor with higher rating is like a 6,000 microfarad cap at the same time period. Like here's one. Would actually be smaller. So this cap has better specs than that cap. 6,000 volt cap, 4,000 volt cap, both the same capacity. Alright, so replacing that should indeed help. I'll replace both of these guys with plastic film caps. Alright, I finished recapping the bottom of the high voltage box, including replacing those two carbon comps with metal film resistors. And it turns out that these two are the filament wires. It doesn't really matter which goes where, but these two do. And they are subtly different. This one is orangish, this one's yellowish, so when I reconnect them, it does matter where they go. Alright, so I'm going to flip it over, and I have one resistor to replace on this side. I'll dust it all off in there, and clean that off and wire it back in, and we're close. And then after that, I need to clean up that mess. Very confusing if you look on the schematic. They show a 4-section resistor. They have R81, A, B, C, and D. 18, 18, 1875. But that's not what you actually find in the set. What you find in the set is we have two discrete, and I think are both 18 ohms. And I think that is original. We have selenium, and we have a fuse. So I would like to replace this with silicon, and I would like to throw a thermistor in here, so I gotta figure out which is going where, and I'd like to replace both of those as well with new resistors. I finished work on the high voltage box and reattached it. I also went through the tubes and discovered that what should be a 6AV6 was a 6AT6. I put the right type of tube in there. And I substituted a 10 ohm resistor for the filament for the CRT. And we're going to throw a little bit of caution to the wind and power this up with the selenium still in place. The two 18 ohm resistors up top appear to be good. There's a slow blow fuse on the other side of the selenium, which is good. So we're going to power this up. Now normally I would do this with the rectifier tubes out just to see if the filaments will glow, but in this case I can't because the rectifier tubes are part of the filament chain. So I figured I was a little bit of precaution to at least replace the CRT with this. So we should get filament continuity, we should get B+, we should get high voltage. Let's turn on and see what happens. So I have my cheater cord hooked up, and here we go. Alright, we do have current draw. You can see the meter in the background. We're drawing 3/4 of an amp. Yep. All the tubes are aglow, I think. It's a little hard to see. I think we're good. Now, simple way to see if we have high voltage is if I bring a fluorescent light near the high voltage box with that lid off, it should light up. I like it when things work. And that thing of beauty. So, we have high voltage. Let us proceed. It also means that we've got B+, and it may seem like just a silly little gimmick, but that means a whole lot of things are going on. It means that we've got filament continuity because all the tubes lit up. It means we have a good power supply, otherwise the high voltage generator wouldn't work, and it means, of course, the high voltage generator is working. So I'm going to go ahead and put the CRT in and see what happens. While I had the CRT out, I cleaned it, and I noticed some marks on it that really make me think this is from an Admiral 19A1 set, because there are two circular marks on the bottom, and the Admiral TV in particular has two cushions that go down there, and it also has a band across the top, and all the marks seem to indicate that. Alright, here we go. So again, current draw, which means we've got continuity. Of course, CRT filaments lighting up. All the filaments have to work. It's either go or no go. All the tubes are aglow. Curious that 6AL5 is doing kind of some weirdness. So that's the one that has that power resistor across the filament. It was kind of glowing and then it's kind of flickering. Makes me wonder maybe this tube is not in the best condition, because with that dropper across it, I was expecting it not to really glow much at all. Obviously we don't see anything. I don't recall which of these controls are what. So I'm just kind of manipulating. Oh. Ooh. Well, we certainly can get a bright dot down here, but we have no deflection. It's all disappointing. Both oscillators are out. That's weird. Now, of course, I haven't checked any of the tubes. I'll turn this set off. One downside to these sets is they were meant as low-cost sets, but these days 12 SN7s are a little pricey, and this uses 1, 2, 3, I think 4 or 5 of them, but basically because of the audio files, I guess. 6 SN7s are more commonly used in amps, but 12 SN7s seem to be impacted just as much. I have a few spares, but not that many, and I've put a save search on eBay hoping to get some deals, and man, they ain't cheap. So I wouldn't expect them all to be bad, though. I'm a little disappointed we don't have any deflection. We have high voltage, we got a spot, which is fantastic. Usually that's a trickier part to get. I would think one or the other of the deflection amps would be working. Oh, you know what? I'm stupid. Well, not stupid, but I forgot something. Okay, I did something stupid. How about that? Now, the horizontal is in circuit, but I still haven't put the vertical coupling caps in place. So that's not going to work too well, is it? So these are the horizontal coupling caps. Those are in place, but the vertical need to go in here. Those are those big, ginormous caps. The ones I want to use haven't arrived yet, but I got some stuff I can tack in place, so let's put those in. Maybe at least, maybe if the horizontal isn't working, maybe the vertical does, so let me get those tacked in place. temporarily I tacked in a couple .0047s, which is what I find in most of these sets. It's 1/10 the value of what the caps that we found in this set. But we'll see how it goes. The caps I want to put in this set permanently should arrive in a day or two. Now for the horizontal, check this out. These are the horizontal coupling caps. They go to this little terminal strip, and look at that. A solder blob fell from up above while I was working on this area and shorted this lug right to the chassis. So let's pick that out. So between that short, fixing that short and putting these caps in place, we just might get a raster. Alright, here we go. We have high voltage. Ooh. Haha. We have a very off-center raster. Let's reach around back here. Okay, that's obviously focus. Ooh, nice sharp focus. But the centering controls don't do anything. Well, that's disappointing. Jeez, I mean they do. Oh, I didn't replace the wiring on those. Yeah. It's with. My brain is not working today. I forgot to replace the wires I had taken out of the centering controls. But hey, I am very, 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 very happy with these results so far. That is a rather bright 7JP4. That's kind of trippy. That would be horizontal and vertical hole. Contrast. Nice, nice. Alrighty, I wired up the centering controls properly, and you probably won't be too surprised to learn that the big 120 ohm resistor across 6AL5 was bad, so that's been replaced. Let's see if the centering controls actually work now. It's vertical. That is horizontal. Alright, I think we are in business. So how about we try fitting a signal into the set now. Alright, fitting a signal in on channel 4. So my selector on 4. Far right is fine tuning. Let's see what we get. One thing I find odd, when you turn this set on, it starts out with a dot, a very bright dot, then the deflection amps kick in, which seems like a bad idea, but now doing a crosshatch pattern, are we actually receiving it? Yeah, I think we are. So let's try, it's horizontal hold. No, I haven't checked any of the tubes yet, we'll get to that. That's vertical hold. Contrast. I've turned the contrast down. We actually kind of sort of see something. Switch to circle pattern. Yeah. Oh, can we get vertical lock? Oh, yes we can. What about that? No, it's not great by any means, but it's something. There's no linearity adjustment for these sets. Well, the way to improve it is to, well, improve the components. So replacing the tubes might help with that. So this must be brightness, and this is contrast. One thing I'm curious about is if I leave this running a while, will the high voltage fade? Which seems to be the big issue with these sets. So I'll leave that going while I dig up a tube tester. Well, I don't think the high voltage is faded yet, but the sync sure has. This is a weird set to work, to borrow some ham terminology. So brightness, contrast, which is gain, and the hold controls. And there's also fine tuning. Adjusting fine tuning now. So I had everything looking good a moment ago, but after 5 minutes it just went to garbage. I'll tell you what though, it sure is pretty all lit up in the dark with all these tubes glowing. And since it is a balmy 4 degrees Fahrenheit outside right now, it's not a bad thing to have going. In fact, I have several sets running right now, including a space heater running in the background, all to add to the ambiance of working on vintage TVs in mid-January. I don't doubt these controls could use a good cleaning. Well, I've got my Hickok 600A ready to fire up. I'm curious to see how these tubes test. I'm hoping we have some bad tubes, which would improve the situation here. I'm also thinking since it's so cold outside and a little bit chilly inside, testing the high voltage fade might not be the best thing to do right now. Although, I mean, even as we're watching, the image is changing, isn't it? That is kind of odd. I think we have some 60 hertz ripple working its way into the video. Remember, there's no shield on this CRT. Well, I don't want to get too wrapped up in the image quality until we test all the tubes, so let's do that right now. I checked all the tubes. There was a marginal 6AG5 and a couple 6AU6s. I replaced those. The rest tested very good. And the set is actually playing fairly well. What I didn't realize is the power control is also the contrast. I'm used to the power being volume, but in this set, it does contrast, and volume is over here, and this is brightness. Had this set playing about an hour, and no high voltage fade. But again, to be fair, it's cold. It's low 60s, I'd say, in the workshop right now. So probably should wait for warmer temps to evaluate that, which are coming very soon. It's supposed to be 40 degrees tomorrow outside, so it may not seem warm, but it's 40 degrees warmer than it was yesterday, so that's a huge change. Vertical linearity, I not only tested all the tubes, but I swapped them around their position, and it's still kind of crummy, so I'm wondering if It's because those caps are smaller than they need to be. So let's pop in a larger value cap and see what difference that makes.